All right, so problem number 1 on tonight's homework says the boundary lines for a discus throw are set up as indicated in red in the picture. Using the dimensions shown in the picture, find the coordinates of the endpoints of the two boundary lines relative to the throwing circle and the angle between the two boundary lines. All right, so what this is asking us to do, it wants us to find the endpoints of these red boundary lines. So these points right up here wants us to find these endpoints right up there. And it asks us to find those relative to the throwing circle. So the throwing circle is in effect going to be our origin. It's we've got our coordinate plane going out like this. We're going to have an x coordinate going out this way and a y coordinate going up to that endpoint. And then we want to also find the coordinates to this endpoint as well. But since these are mirror images of each other, the boundary lines here are symmetrical about this center line. Once we find these, it'll be easy to find this other endpoint. All right, so we're told on our paper that from the center line to the outer edge here is 24 meters. It's 48 meters across. It makes sense that it would be 24 meters to one side. And so we know already that our x-coordinate is 24 meters. So we could already put that out here. We're trying to find the coordinates of this point. Our x is 24. And now we need to find our y. So let's call this length here y. We know this side of our right triangle now, this right triangle that we've created. We know this side. We know the hypotenuse is 80 meters. And we've called this y. So using the Pythagorean theorem, we know that 24 squared plus y squared is going to equal 80 squared. So let's set that up. So we've got 24 squared plus y squared equals 80 squared. All right, so 24 squared is 576 plus y squared equals 80 squared is 6,400. And now we're trying to get y by itself, so let's subtract 576 from both sides. And we get y squared equals 5,824. And then take the square root of both sides. We get y equals plus or minus, but since this is a distance, we can ignore the negative answer. And let's take the square root of 5,824. We get about 76.3. That's rounded to the nearest tenth. So 76.3 is this coordinate here, so we can plug that in. So 76.3 that's the coordinates for this point up here, which means that the coordinates for this point is going to be negative 24, 76.3. Because we're going back in the x direction, or going back along the x-axis, and then we're going up again, so in the positive direction on the y-axis. So now we found those two. What we're left to find, it also asks us to find the angle between these two boundary lines. So we need to find this angle here. And to do that, let's start by finding this angle here from our end line here up to this boundary line here. And we can do that. We know that we're given this distance here. We're given this distance. We know that this is 24. The hypotenuse here is 80. And since, let's call this angle theta, we know, since we know the adjacent side, we know the hypotenuse, let's use cosine to find this angle. So we've got the cosine of theta is equal to 24 over 80. So the adjacent over the hypotenuse. Now we can take the inverse cosine of both sides. We get theta equals the inverse cosine of 24 over 80. And let's plug that into our calculator. The inverse cosine of 24 divided by 80 is 72.54. Let's just call that 72.5. So that means this angle right here is 72.5 degrees. Which means that this angle over here is also 72.5 degrees. And so together, that makes up 145 degrees. The 72.5 plus 72.5. And all across here, since this is just a straight line, this whole angle would be 180 degrees. So we can take 180 degrees minus our 145, and we find that this angle in here is about 35 degrees. So the answer to the question is that the end points are 24, 76.3, and negative 24, 76.3, and the angle between the boundary lines is about 35 degrees.